In this video, we'll be talking about Project 4, the vapor pressure of a pure liquid. In this experiment, we'll see the temperature dependence of the vapor pressure of a pure liquid, in this case, cyclohexane. We can see that pressure changes exponentially as a function of temperature. We should think about that in terms of how exactly the intermolecular forces are changing as we're going from a solid to a liquid to a gas, and why we would see a big jump in that pressure. We will end up using the Clausius-Clapeyron equation, which I've written up here. So again, if we have this exponential relationship, if we then convert our data to the natural log of pressure versus 1 over temperature, we actually see we can get a straight line. And according to this, if again, if my y is the natural log of pressure and my x here is 1 over t, then I can see that then the slope of my line here becomes negative delta H over R, where delta H here is the enthalpy of vaporization. So we can use the data collected to calculate the enthalpy of vaporization for cyclohexane. The data will be provided for you, but it was collected in the lab using an apparatus that has a piezoelectric sensor. So the cyclohexane will be contained in a vessel, and then at atmospheric pressure, we can set our sensor to a certain voltage. And then the piezoelectric sensor, how that works is it produces an electrical response when there's some mechanical stress. So if we have some pressure on this sensor, we will see a readout as a function of voltage. So we can set our voltage at 10 volts at atmospheric pressure. And then to get our next measurement is we'll actually pump out all of the air that's in the vessel. So we'll actually end up freezing the cyclohexane so that we can pump out all of the air in there. So then when we start heating it up again, the only thing that's in the vessel is the cyclohexane and no additional air. So then this vessel is going to be placed in a beaker of water where we can then monitor the temperature. And we'll slowly increase the temperature of the vessel. And then the piezoelectric sensor, as our cyclohexane goes through the phase change, particularly from liquid to gas, where the pressure in that sensor will increase. And so we'll go from 0 voltage to, as the pressure of cyclohexane as it converts to a gas, we'll have some stress on the sensor, which will then increase the voltage. And again, once we get up to our kind of 10 volts again, so we should see the increase there. So you will be collecting this as a voltage. You will use this information to convert your voltage to a pressure. So you can get a plot like this. Then you will process your data to obtain the linear relationship to get the slope, and then you'll calculate the enthalpy of vaporization using this line, and then you'll compare it to some literature data.